The Apollo Lunar Module was unlike any spacecraft ever built, with thin walls, no wings, no heat shield, and experimental technology. It was designed solely for space and the moon. His story is as fascinating as the moon landing itself. Landing on the moon in the 1960s was a massive puzzle. NASA could have used a full-size spacecraft or built something smaller. They chose an entirely new approach, a craft made just for the moon. Grumman was tasked with designing it, and the result was unlike anything anyone had seen before. The first prototypes were overweight, meaning they could not have been carried by the Saturn V. Engineers had to thin the aluminum pressure walls, thinner than cardboard, and only a fraction as thick as typical airliner skin. Tom Kelly, the LM's chief designer, recalled, "You could easily, if you were careless, put your boot right through that wall." From a distance, the lunar module shimmered gold, but that foil was actually layers of mylar and Kapton insulation, essentially plastic films with ultra-thin aluminized coatings. Some of these layers were thinner than a strand of hair, and were designed to protect against extreme temperatures, not impact. A micrometeorite strike posed a real danger. While the LM could withstand some impacts, a second strike in the same spot would have been risky. Its thin aluminum walls were meant to deform and absorb shocks rather than remain rigid. "Even dust can damage a spacecraft," says NASA engineer Bruno Sarli, referring to the kind of challenges future Mars missions could face. The LM's bizarre angular form suggested toughness, yet it was among the most fragile spacecraft ever built. To save weight, astronauts didn't sit. They flew standing up, strapped into elastic harnesses, which allowed engineers to shrink the windows to small triangles and reduce significant weight. And when it was time to rest, there were no bunks. Astronauts slept in thin fabric hammocks, feet almost touching the control panels, in a space the size of a small car. One really interesting fact about the lunar module is about its descent propulsion system, which was the first rotable engine NASA ever used in spaceflight. Before this, rocket engines were basically on or off, with fixed thrust. Landing on the moon required finesse. Astronauts needed enough power to slow down from the lunar orbit, but also the ability to adjust thrust smoothly while hovering or maneuvering near the surface. The lunar module landing gear was retractable. Originally designed with 5 legs, it was finalized with 4. Each leg had a honeycomb structure in its telescoping cylinder to absorb the shock of landing, allowing the LM to settle safely even if one leg touched first. The legs also had probe rods. When they contacted the lunar surface, a light inside the cabin would alert the astronauts to cut the descent engine at the right moment. Every detail was carefully engineered for the moon's unpredictable surface. If the thin wall seemed risky, the ascent engine was even more terrifying. It had to lift 2 astronauts off the moon along with samples of lunar soil of more than the weight of a single person. What made it even more critical was that it was the crew's only way to return home. If it failed, the astronauts would have been lost. Tiny but critical fixes made a huge difference. Engineers even added a mid-step on the ladder so astronauts could climb safely without damaging the module, used tape to hold fragile insulation, routed every pipe efficiently, and re-evaluated every nut, bolt, and panel. Thousands of engineers worked under intense pressure, racing to land humans on the moon before the 1970s. Delays, doubts, and budget overruns were constant, but failure was not an option. By 1969, the lunar module was ready. Fragile but practical, it worked perfectly. The moon landing wasn't just an astronaut triumph, it was engineers' victory over doubt, gravity, and impossibility. The Apollo program involved 400,000 people in total. In all, 13 lunar modules were built, 10 of which flew in space and 6 actually landed on the moon. Today NASA is preparing the Artemis program, which will use the new human landing system to return astronauts to the moon. The HLS is still in development and is currently estimated to be ready by 2027, serving as a modern successor to the lunar module. And as a curiosity, would you dare step onto the moon in a spacecraft this fragile?